Hi, my name is David Lamb, and today this video will be about the intro to the Pythagorean trig identity. So looking at this right triangle right here, the B is the base, A is the height, and C is the hypotenuse. So from looking at this triangle, we know that this is related to the Pythagorean theorem. So the Pythagorean theorem says A squared plus B squared is equal to C squared, the hypotenuse. And essentially in this video, I want to explain how we can relate trig functions to the Pythagorean theorem. So using this angle right here as theta. So we want to remember so ka toa. So is the opposite of a hypotenuse. Ka is adjacent over hypotenuse, and toa is opposite adjacent. But we won't be using toa for this video today. So looking at theta, sine is opposite hypotenuse. So that would be a over c. Sine theta is equal to a over c. Cosine is adjacent over hypotenuse, so it would be b over c. So cosine theta is equal to b over c. So if I want to relate these two to the Pythagorean theorem, I could essentially square the sine theta and cosine theta. So it would make sine theta equal to a squared over c squared, and cosine squared theta will equal to b squared over c squared. And from this, I could add them together and get something that would equal to something like this. So adding these two together, sine squared theta and cosine squared theta, would equal to a squared plus b squared over c squared as the denominator. So if we were to add these two together, a squared plus b squared is essentially equal to c squared from the Pythagorean theorem. Look at the triangle. A squared plus b squared equals to c squared. So we simplify this, and it would be c squared over c squared, and simplify c squared over c squared, that would equal to 1. So essentially, sine squared theta plus cosine squared theta is equal to 1. And of all the trig identities, sine squared theta plus cosine squared theta equal to 1 might be one of the most important trig identities. And the importance of this identity is that if you give me the sine of an angle, then I can solve this equation for the cosine of that angle, or vice versa.